Supposed to find the general solution to this exact differential equation. So this is separable, which is like where you can multiply that dx to both sides so that we have just things in terms of x and things in terms of y on one side or the other. We wouldn't be able to do this if the right side was tangled up with the y variable somehow. But now we can find the antiderivative of both sides. This side's going to be with respect to y. So what's the antiderivative of 1? It's y, because the derivative of y would be 1. And then we should say plus some constancy here, but we're going to see that in the end. And then the antiderivative of the right side, we'll go term by term. The antiderivative of this is going to be 2 to the x. That's because when you take a derivative of an exponential function, the derivative is itself times a natural log of the base. Oh, sorry, that was supposed to be a 2 in the original problem. That doesn't make sense. I would need something way more complicated. Very sorry. That's supposed to be a 2 at the beginning, or else I guess I don't even know what we could do to start finding that antiderivative if it wasn't a 2. And then this term here, we've got this term. Its antiderivative is 2 to the x. This term here, I put up the table of inverse trig functions and their derivatives. Just remember we're finding antiderivatives, so we're working backwards. So if I try to identify this somewhere in this table, it's right here. So the antiderivative of 1 over the square root of 1 minus x squared is inverse sine of x, arc sine of x. And then it's plus some constant c, right? Now, this is almost a solution. You just need to subtract this c from both sides, and a lot of students at the beginning might say 0, but you really should be specifying these are two different arbitrary constants. Okay, if you take an arbitrary constant, you add or subtract an arbitrary constant, then you've just got a new arbitrary constant, right? The solution is 2 to the x plus arc sine of x plus some arbitrary constant c.